Hello class, in this video we are going to discuss estimation, and this is the case 1. We talked about the 4 different cases, so in this case we are just going to talk about case 1, and if you have any questions about other cases, you can ask me. So this is just the reminding you that all the formats that we went through are pretty similar, and as you go through, there will be some differences. Okay, so but we'll talk about that as we go through here. So case 1, we're gonna go over this question here. Okay, so let me just read through, and then I'll just go through the entire process here. Okay, when people smoke, the nicotine they absorb is converted to the quatinine, which can be measured. A sample of 40 smokers has been quatinine level of 172.5, assuming the population mean 172.5. Now that is wrong, so I'm going to change that. Okay, I'm going to change this to, now remember, I'm going to make this, okay, I'll use my red up here. So we are going to change that to 170. Okay, and the sigma is going to be 119.5. Okay. Find the 90% confidence interval estimate of the mean quatinine level of all smokers. Okay. So let's just go through. So, remember that we went over the entire process of the step that we went through. So I'm going to look at the those rows that we talked about, right? So let me go over that here. So the first one is going to be the n. So if you look at the n, hang on. So n is equal to how many people? We measure the 40 smokers, right? So that will be a 40. Then we have x bar. Okay, so from the sample of 40 smokers, we found out that it is going to be 172.5. Now here, the population standard deviation, sigma is given, right? So the sigma is equal to 119.5. Now then, we're going to have to find the, let me see, I just need to go, we have to find the degree of confidence. I'm just going to write that here. Degree of confidence or confidence level. That would be the 90%. Okay, now let's find the critical value for 90%. Now remember that in order to find the critical value, okay, remember that you're going to have to divide that alpha by 2, divided by 2. So over here, we got 0.9. So that means that, the alpha here is going to be divided by 2. So that will be a 0.1 divided by 2, because if it's a 0.9, then the other two areas are going to be add up to 0.1, but we want this separate area, so that will be a 0.05. Okay, and same thing over here on the other side also. So alpha over 2 is 0.05 again. So now we're going to have to find this, the critical value, z, alpha over 2, and that will be a minus there. And over here is going to be z alpha over 2. So let's just go to the table, and we're going to find what the 0.05 the critical value is. So if you go down there, it will give you the minus 1.645, but we're always going to use a positive critical value, so that will be 1.645 here. Oh, no. Okay, let me go up here and erase all this. Okay, so let me erase this. Okay, so that will be 1.645. Okay, now we need to now find the what we call the margin of error, right? So the margin of error here is going to be the z alpha over 2 times sigma over square root of n. So let's just plug in. You got 1.645 times the sigma is given to us as 119.5 divided by square root over 40. Okay, so let us find the what margin of error is. Right? So let's find out. I'm just going to calculate this, and the okay, so give me a second. I'm going to calculate this. Okay. Okay. So here I have 31.08. You might get a little bit different number if you round it up, or more or less. But the calculation gives me a 31.08. Okay. Now let's set up the confidence interval now. So remember that confidence interval says x bar minus margin of error. Okay, and x bar plus the margin of error. So let's plug that in. So the x bar was 172.5 minus margin of error is 30.08, and the 172.5 plus the margin of error of 31.08. Alright, so let's find out what we have on the left. So we have 172.5 minus 31.08, and I have 141.42, and on the right hand side we have 172.5 plus 31.08, and I have 203.58. Okay, so that's going to be our confidence interval. Now we will need to write the interpretation there. So we are 90% confident, okay, that interval from 141.42 to 203.58, okay, does contain, okay, true value, okay, mu. Now remember, I told you that you cannot say this is the between the 141.42 and 203.58. That's not how we interpret this. Okay, all we're saying here is that we don't know exactly what the mu is, but every time we take the sample, it will indicate that 9 out of 10 times that will contain the true value mu that we are looking for. Okay. Now remember that the when you do this on the test, okay, you must use correct table. So since this is a, you know that the sigma is known, I'm just going to point that out here. So right here, okay, the sigma is 119.5. So if you know the sigma, then we know that we have to use normal distribution table. Okay? And that's why you see that Z over here. Okay? If you don't know what the sigma is, let's say you know the sample standard deviation S, then you have to use the T distribution table, and this becomes a T alpha over 2. If you are estimating population proportions, okay, you're going to use a normal distribution table, then you will have to use a Z again. And if you are using the estimating population standard deviation, then you know you're going to have to use the chi-square distribution, and this becomes chi-square alpha over 2, and that's going to be, you get that from the chi-square distribution table. Okay, so just to make sure that you recognize the which case that you are trying to estimate, and according to that, you're going to have to use a different table. And then, according to the table, you will get the critical value. And then, you will have to find the margin of error from there. Okay? So, this is, remember, this is just case 1. I'm just doing this. And make sure that, you use the correct table there. Okay? I am going to do more, if you have any questions, I will go over the, questions with you. But I'm just going to do one case 1 for the estimation. And then I'm going to do the same for the hypothesis test. We're just going to do one, okay, case that I'm going to select. Alright, so thanks for coming. Then I'll see you in the next video, which will be the hypothesis test. Okay? Alright, thanks.